Hi everyone, thanks for joining us here. So this is exciting that I see faces. So this is our first interaction after a while. So thank you, and thank you very much, Esther, and the rest of Intertraffic and Rai team for putting this together. So give us the chance to come here and then have this one-to-one discussion. My name is Ali Murtazavi. I am your moderator for today. So I am the founder of DAFTech. I'm working on this project with this great team. But first of all, I just want to introduce quickly our great panel here. And first of all, thank you very much for coming over here from California. This is a long travel, and so they are here to share us with their thoughts. So I start from left, Team Hale. Liam Pedersen, and then Randy Wasaki. I'm going to go through their bio at the beginning of each presentation. But today we want to talk about this special solution that we are using to alleviate traffic and then improve safety within Contra Costa County, which I'm living in also. And this is by implementing AI to reduce traffic and improve safety, which we will talk about it, and even in corridors and also on intersections. So our panels will talk about and they reveal their view about this problem. So Tim will talk about his perspective from public sector and how it is aligned with his vision about Contra Costa County. Liam will talk about the technical implementation. He's from Nissan. He's talking about the OEM view and vision about this problem. And then at the end, my friend Randy is going to wrap up with talking about the implementation side of the AI in the cloud, which requires data and then also infrastructure or compute infrastructure. And he's talking about the solution that is kind of innovative for transportation to kind of implement these kind of solutions. Tim is Contra Costa Transportation Authority Executive Director. He is responsible for the overall management of the authority, including implementation of projects and programs identified in Contra Costa County voter-approved sales tax measures. With this quick introduction, I pass everything to Tim. Thank you. Here you go.
Yeah, thank you, everyone. I really appreciate the opportunity of being here. Thank you, Esther and Ali, for inviting me to speak with this great panel. And it's actually a real treat because not only are we all friends on this panel working together on this project, but kind of a fun fact is Randy was actually the former executive director of Contra Costa Transportation Authority. So a lot of what I'm going to talk about is really part of the vision that him and I developed as we were working together at CCTA. And now we're kind of implementing it together in different roles. And it's been exciting to see it come to reality. Just before I start, a little bit about Contra Costa Transportation Authority. We are a local county transportation agency in California located in the San Francisco Bay Area, more commonly known as the East Bay. We're about 1.2 million people in Contra Costa County. And so we are also the state designated congestion management agency. And so we're responsible for monitoring and identifying transportation mitigation measures along our congested freeways and corridors in Contra Costa County. And then also, we're really known for innovation. And so CCTA actually founded Gomentum Station, really with the vision of Randy there at the executive director. And this is really a 5,000-acre secure autonomous vehicle test bed that we leverage through all of our projects and programs, as well as really gives us a front row seat to the future of how to see where transportation is going and also working with the private sector. So we're only 20 people at CCTA. We manage a $2.7 billion suite of programs and projects. And so we implement programs for transit, for ferries, for people with disabilities, seniors, but also deliver and construct large capital improvement projects and also smaller ones like bicycles and pedestrian type projects. So what I wanted to talk about is really our Innovate 680 program. And through this program, we actually developed this fully integrated, multimodal corridor that's really now powered by the AWS cloud. And through this, we use a proactive approach, a performance-based approach, to really develop 7 strategies. And through that 7 strategies, we went through the corridor and identified real critical hotspots, as well as closing gaps in lanes, really to have continuous flow, and then also how to improve transit in the corridor. So we're adding express bus service, as well as local feeder bus service, to make sure that it's connected, it's integrated, and then also prioritizing it with bus on shoulder lanes on the highway, as well as priority lanes on the local arterials. And then also using innovative operational strategies. How do we leverage technology to really improve traffic flow, synchronize traffic flow, and coordinate all of these different modes of transportation comprehensively in the entire corridor, not just focusing on the freeway, but also on the local arterial system and through the community. And then also how to prepare the corridor for the future. And that's what we're going to talk a little bit more about today, is how do we set this environment up for connected, autonomous vehicles and really prepare the corridor for the future. And then how do we actually get people to the corridor? And so through a network of shared mobility hubs. And so if you can imagine, and actually in Amsterdam, it's great here, by the way. I mean, the bike infrastructure, everything here is amazing. And I wish we had this type of infrastructure in the United States and in Contra Costa County. But we are trying to develop something to where you can walk or bike a half mile away to a shared mobility hub and have personalized mobility options that would essentially guarantee you seamless travel through a completed integrated transportation system. And that would be connected through a mobility as a service platform. And so you're able to do origin, destination, be able to plan, schedule, pay, receive rewards for your trip, and then basically through use those incentives to change travel behavior in the corridor to really meet our goals for mode shift, improving safety, as well as our sustainability goals to reduce greenhouse gas emissions. So CCTA was the one of 8 recipients in the United States for an automated driving system grant. And through this grant, we were the only local agency in the United States to receive this grant. Everyone else was at either the Department of Transportation or academic like university. And so we took a really different approach to how can we proactively look at safety. And so by looking at identifying near misses, looking at hard braking, hard acceleration, looking how we can leverage connected vehicle data to understand where those hot spots are at in the corridors, and then be able to look at how we can avoid those near misses, leveraging this connected technology. And so by taking that data and collecting it, US DOT is able to do rulemaking, able to do performance standards, and then also get an idea of these new mobility choices that we can provide in the corridor. And then also implement innovative operational strategies. So the first project was really focused around the growing aging community. So in Contra Costa County, I mentioned we have 1.2 million people. About 14% of those people are over the age of 65. And that population is supposed to double by the year 2035. And so we wanted to pick a community, Rossmore, the average age of 77, and really learn how this technology can support them in their communities by leveraging our level 4 shared autonomous vehicle on a fixed route and be able to get these people to the community center, to the grocery store, to the theater, and how to use that technology to maintain and improve those people's quality of life. And then also the county hospital project. So this is where you have a growing rate of absenteeism. So people don't have access to transit options or transportation. So really serving those underserved communities and making sure they have the ability to get to those hospital appointments and be able to maintain their health, maintain their quality of life. And so we're planning on running an on-demand, level 3 or higher, autonomous vehicle, connected vehicle, to get them to their appointments and really integrate this technology with the health system. So we're going to talk a little bit more about this today. We're partnering with Nissan, Verizon, Amazon Web Services to really make this fully wireless connected network along the corridor. So this is truly, I love this graphic because it really shows the vision for the corridor of what we envision. And so if you can imagine a complete a complete wireless communication system that's connected, it's real time, using vehicle to everything so the vehicles can connect to the infrastructure, and we can be able to communicate with these vehicles to help improve traffic flow, improve safety in the corridor, but also expand that technology to arterials, and we can actually avoid collisions on our local road intersections. Also improve safety with our bicycle and pedestrians and meet our Vision Zero goals. And that's what you're going to hear more about from Nissan and AWS today. And then also by prioritizing vehicles in the corridor, so able to prioritize transit, right? So if you look at the on-ramp here, you'll see the transit and the bus on shoulder lane and being able to prioritize that through an on-ramp by holding that ramp meter red a little longer to meet our safety goals in the corridor, but also prioritizing local traffic and harmonizing that from the time you leave your house, down the local arterial, all the way to the freeway and on the freeway, really using the connected and autonomous vehicle technology that Liam's going to talk about here in a moment. So that really concludes my presentation, and really looking forward to your questions at the end of the presentations.
So our next speaker will be Liam Pedersen, my friend and an old colleague at Nissan. Liam is the Deputy General Manager and Chief Technology Advisor at Renault Nissan Mitsubishi Alliance at Silicon Valley. His team does work in autonomous driving, transportation systems for smart cities, electric vehicles, and vehicle-to-grid integration. So with that, I'm going to pass it to Liam. Go ahead.
Oh, thank you, Ali. Thank you, Tim. Thank you, everybody. So, yeah, I'm really pleased to be here. So my lab, where we operate a sort of center of excellence in AI for Nissan, and we do research in autonomous vehicles, especially level 4 vehicles. But increasingly, we're also, if I can go forward.
Green. Yeah.
There you go. Increasingly, we're also looking at connected vehicles and smart cities, right? Smart city integration. And what exactly is a smart city? Well, in my view, a smart city, as far as I'm concerned, is getting data from our assets, from our connected cars, from traffic lights, from other sources, managing that in the cloud using AI, and then trying to actually improve the efficiency and solve these problems that cities have, like safety and congestion. And this is actually, for me, is really interesting because my background is in the space industry, where I used to work on very rovers that would operate in a distant area, and they were actually backed up by a huge amount of AI on the ground, which is the cloud. So let me talk about congestion for a moment. Congestion is a big problem, right? It's a waste of time. My colleague Tim has to deal with this in the 680 corridor close to where he works. And besides the waste of time, though, it's also a big waste of energy because so much energy is wasted in these stop-and-go motions of cars. It's actually excess braking. It's something like 20% additional fuel use. And congestion usually happens because of too many people on the road. But once you exceed this critical threshold, you start getting these things called phantom traffic jams, these dynamic slowdown events, which you can see in this video over there. And as you can see in the movie, there's no reason for those cars to be stopping. They're stopping because of the way that people drive, right? People accelerate, and then they stop, and they accelerate, and they stop. Now, one way we can mitigate this, the traditional way, is through using metering lights and other ways of trying to reduce the density. But there's also another way, using AI to manage this. This is work from colleagues I'm working with at Arizona State, now at Vanderbilt and UCB. But imagine, see that vehicle with the arrow? That's currently being driven under human control. And in this is a real simulation. You can see the stop and wave. And now the cruise control of that vehicle has been adjusted so that vehicle itself can actually start to moderate the traffic jams. So imagine if we had vehicles like this interspersed throughout the freeway system, driving in such a way that they can dampen these waves, these traffic jams. Now, that's not necessarily going to stop the traffic jam, but it's going to keep everyone moving more smoothly so we don't get these excessive brakings, and as a result, we don't waste so much fuel and we decrease emissions. Now, work up to now is focused on using reinforcement learning on the car to learn the right control policies to actually dampen this traffic jam. But what we've come to understand is that this works so much better if we have a cloud-based system that is directing vehicles in different parts of the traffic pipeline so that you have upstream vehicles given the instruction to slow down vehicles or slow down input, and then downstream vehicles that have slightly different parameters on their ACC, such as to dampen this motion. We also have another project together, turning to the concept of safety, right? So consider vulnerable road users right now. In the last 20 years, pedestrian fatalities have gone up tremendously. And this is happening even as our cars become safer and fewer people are dying per vehicle mile traveled, but pedestrians and cyclists are being hit and injured more often. And this happens a lot at intersections. And frequently the cause of this is because the driver of a vehicle is simply unaware of the existence of a pedestrian. If we could use the head-up display or other warning system, the infotainment system in our car, to give our drivers an advance notification of a pedestrian that is in the way, especially someone who is occluded. So if we're turning right, as you can see in this image, if there was a pedestrian on the other side of those cars, could we provide a warning? And we could do this using sensors in the car for pedestrians that are visible, right? But the problem with sensors in the car is they're expensive, and most cars don't have them. And sensors in the car cannot see a pedestrian that is around the corner that you actually have a collision hazard with. So what we are doing is using connected intelligent infrastructure sensors on traffic lights. These connect to the local cell phone network, and then they're in a very low latency, high bandwidth communication with an edge node in the cloud. And the reason we have an edge node is so that we can speed up the computation, speed up the reaction time. And the AI in the cloud decides which of the many possible pedestrians that we see in an area constitute an actual threat, right? Because what we do not want is a system that starts warning you of every single pedestrian on the road. That would just be useless. So that AI in the cloud figures out, okay, that pedestrian there is unseen, they're about to cross the road, they're in your route, and then they can send a warning or notification back to our driver to help them actually reduce this rate. And furthermore, not only do they connect to drivers, but they can also, this service actually, can connect to people through a smartphone app. So pedestrians themselves can enhance their safety by both getting a warning, but also by sharing their location. I mean, with their permission, of course, to help drivers avoid them. And here I have a quick video. On the left, so we've done this on our infotainment system. And on the left is what it looks like in the head-up display of one of our vehicles. If you look very carefully in front, you can see the speed of the vehicle.
Caution,
And there you see a little warning. You see that little red warning there.
That should do.
And as head-up displays become more common, this is a very good way of letting drivers know what's in front without actually taking their eyes off the road. And on the left is, of course, the pedestrian experience. This is Current, he's reading about the Ukraine. And so this way he gets, both road users get to actually enjoy the enhanced safety that this system can offer. So I'd like to close on that, and I look forward to your questions. Thank you.
Thank you very much. All right, so our next speaker is my old friend and also mentor, Randy. Randy is the leader of state and local transportation at Amazon Web Services. Before that, he worked in public sector for a long time, and I know him since he was like the head of California Department of Transportation many years ago, and then he became Contra Costa County Executive Director, as Tim mentioned. So with that, I'm going to pass it to Randy. Please.
I'm at Amazon Web Services only because we got the Automated Driving System grant when I was at CCTA. And I told Tim, I said, Tim, you have two choices about storing the data on that ADS grant. You're going to end up losing your offices for server racks if you want to store all that connected vehicle data, or go find the best cloud you can find. So he came back. And he said, Amazon Web Services, so we signed a contract. They found out I was going to retire, and they said, why don't you come work for Amazon Web Services and lead the transportation division? So here I am. And the reason why I'm showing, this is the team. So we cover the United States, and we got 8 sub-verticals. I'll talk a little bit about that. But the guy on the right is Tyler Subasic. He actually focuses on airports. Amazon Air, 4 years. He's been with us now for about a year. Operations, he knows the airport directors. The person on his right, or to the left of Tyler, is Tracy Trexel. So Brendan, that's who's going to be the RUC person, or road user charge focus point. She focuses on tolling and Amazon Web Services and transit. That's me next to her. And then the reason why I'm showing this picture, the guy on the left is Ravi Talluri. Ravi Talluri has worked for 3 OEMs in his life before he came to Amazon, and then ultimately Amazon Web Services. So he worked for General Motors, Ford, and Capgemini. So he worked on the data, connected vehicle data platform for Ford. And so we have a pretty good team focused on connected vehicles, trying to figure out how do we optimize those vehicles in the future. So we're building the infrastructure, the platform now to accommodate that for the future. So we focus on airports, seaports. I know you can read that, but I love these pictures. I love the kind of the whimsical look. You saw a little bit of that in Tim's slides. I want your slide, by the way, that shows all the different things in the cloud. I like that version of the cloud. Here's our global infrastructure, and the reason why I think this is important, we have 25 different regions, availability zones, so you can cross over so you don't lose service. So Netflix is a user of AWS's cloud, and the reason why is you've got unlimited storage, you've got scalability, elasticity, and you're not going to see Jack Reacher streaming video hesitating. So when your favorite movie is on at 6 o'clock in the evening, when everybody else is dialing in, much like Amazon Prime Week, you still get the same service. So those are availability zones and points of presence. So these are edge. So this is edge computing. I have a slide on edge computing. I think it's going to be important in the future. So why is now the time to innovate? So I gave this speech in TRB. I think, Rob, you might have seen it. Aging infrastructure. Our infrastructure is old, and so we have to fix the infrastructure. Funding, there's more money today than there was the last bill. So you got $1.2 trillion for transportation, $650 billion for the existing extension of FAST Act for better purposes, and then $550 billion of new money, competitive money that I know Tim's going after. Liam talked about smart cities. Equity, how do you know that the project that you're working on is equitable unless you have data? Otherwise, you're just guessing. So you can run data analytics on the storage of that data. You can start figuring out, is this project equitable? Because that's a big issue, at least in the United States, with the Biden-Harris administration. Software is getting more complex. It's helping you out. Containers, I'll talk a little bit about outposts. And then artificial intelligence and machine learning. And so Liam talked a little bit about that in the cloud. So let's focus on the cloud. Your software packages are going software as a service. So you no longer, in my day, I remember in 1990, I left Fresno district for Caltrans, went to Sacramento to start project management. And we were running Primavera at the time. And in order to store data, that much data for 800, 900 projects, I had to go to the governor's office to get approval to buy a PCAT with 1 megabyte of storage because it was so outlandish in those days. Why do you need a megabyte? So you have unlimited storage today. You have access control for security, cybersecurity, document management. You're always working on the latest version. So you don't have version X, somebody's working on version Y. Access anywhere, so you can actually access the cloud anywhere you are in the world, probably from space as well if you have the right setup. Outpost is a container system to bring the storage unit closer to the host because you're going to have to run calculations on the edge to lower that latency. So if you want millisecond latency, you're going to have to bring your storage facilities and your edge compute power closer to the edge. And then you have artificial intelligence and machine learning. These are the reasons why you should think about the cloud. You have agility, so Amazon Prime Week, you have the same service. You have scalability, elasticity, cost savings, so you only pay what you use. It's much like a utility. When you use it, you turn the switch on, you pay. When you turn the switch off, you quit paying. Yeah, I mentioned elasticity. Innovation, you can test your theories faster. If it doesn't work, shut it off. Go back to the drawing board. If it works, you can provide better services for your customers. You're going to need that when you start dealing with connected vehicles in these smart cities. And then global reach. So the world's getting smaller. You've heard that term. Well, I imagine with connected vehicles, the world is going to get smaller, so you're going to have global reach because you're going to have regulations that have to span the globe in theory. So machine learning, I mentioned machine learning. Liam's a big machine learning guy, so we have SageMaker, so there's technologies that are designed to work on the edge to provide machine learning. So we have a product called Panorama. Panorama is an edge box. There's edge computing. It takes a direct feed off your camera. Your camera typically is dumb, unless you have a new camera that has edge computing box built inside of it. But what you do is you run models off that picture, and you could teach that camera to see things that you want them to see. We're working with an airport now to take a look at parked cars. So currently you don't have enough staff to manage the 3-minute rule, let's say, for parking at the departure or the arrival area. Those cameras are watching. And at the end, what they do is they ping a smart device or your watch and say, hey, zone X, person been there longer than 3 minutes, tell them to move. That's edge computing, bringing the compute power closer to the host. In this case, it's going to be your cars. There's a lot more sensors, by the way, out there, as you know. And so you're capturing more data. And then twinning. So what you're going to do ultimately is digitize your cities. You're going to have to store all that data, build a twin. It's much like manufacturing. You can mess up the twin, go back to the drawing board if it doesn't work. If it works, make those modifications. Once again, innovation, less risk. You're liable, probably going to keep your job. When you work in the public sector, if you take risk and it doesn't work out right, normally. This slide right here. So this is an example of data storage. So there's more video being stored today, and it's increasing every 2.5 years. However, only 98% recorded visuals never, so only 2% of all the video that you store is analyzed. The other 98% is not analyzed. So you're going to start analyzing that data, get better information to make better decisions. So these are things that these technologies will enable. You've got smarter cities, performance. You can increase productivity. These are things that we want to help you with. And no matter what cloud you store your data on, you're going to have the ability to do data analytics. You can have hybrid, you can have on-premise, and then cloud versions. If you want to store your data in your office, it's secure. You want it there, you can do that. And you can store the rest of it in the cloud and run software packages on a hybrid basis. So thank you very much for your kind attention, and I look forward to answering your questions.
All right, perfect. I just want to start with our panel discussion, just with one question, and then I pass everything to you on the audience to ask the questions. So I know that, this is my question from the panel. So we talk a lot about technology. It seems like technology or high tech has the solution, but when we get into transportation, it becomes very complicated. So I just want to hear each, panel's, kind of like point of view of that, what their challenge is. So I start with Tim because he's from the public sector. And I want to see what you think about the challenges for implementing innovation. Please.
Yeah, thank you, Ali. I think for the Innovate 680 program, and a lot of what we're seeing is just, it's really outreach, education, and gaining the public support on kind of these new technologies and how it's really going to help them on a day-to-day basis. And really reaching out. So we've set up a program within the corridor. For example, we just did a travel behavior study in the corridor to understand what people's travel behavior was pre-COVID, post-COVID, and what they may or how they may change their travel behavior after COVID. And so this gives us a lot of data insights in terms of how we want to deploy the technology, how we're actually using it to help their specific needs. So for example, like on transit, it's very obvious, right? They want reliability, they want efficiencies, but it's also they want to have Wi-Fi, they want to have power, they want to be able to work from the bus. And so a lot of those things that may seem very apparent are just things that we're trying to understand in the public of how to implement this technology. And then the other thing is in terms of autonomy and connected vehicles is as you get into the technology, how to really teach them to understand, okay, now this vehicle is going to basically be controlled by the system, right? So you're going to be metering flow as Liam was showing in this graphic. This vehicle is now being controlled by the infrastructure, right? And it's monitoring and harmonizing flow with all the other traffic that's in the corridor. So that concept of letting go and trusting the technology is a huge factor in terms of deploying technology along the corridor and also throughout the world. And so I think those are some of the primary challenges. I think the other one is working with our partners. Like for example, a lot of this technology is operated in silos, right? So if you think about, we have 19 local jurisdictions in Contra Costa County, and each of them are operating their traffic signals and maintaining their infrastructure in different ways. And so by really developing this fully complete integrated transportation system, it has to get buy-in from our partners. And so we have to really, how do we integrate and pull all this information together in the cloud and then also monitor and actually change the infrastructure and change the way we actually operate the infrastructure to really make this fully integrated transportation system. And I think to be able to do things like Innovate 680, it also means that as CCTA, we also have to advance as an organization to support things like shared mobility hubs and first and last mile options, as well as working with our public sector partners to implement a lot of this new technology. Because these people, the technology we're implementing, they don't know how to actually maintain this infrastructure. And so now we're talking about performance-based maintenance contracts and making sure that the technology is being maintained in a more on-time, regular basis every 24 hours, every 48 hours. And so it's a different mindset where maintenance and preservation may not be a priority. It has to be now your number one priority in order to keep the system operating the way you need it to enable the fully integrated transportation system.
Perfect. Liam?
Thank you. The biggest challenge actually is making all these great technology nice to use for people that drive, right? Imagine if you're a driver and your car is being controlled from the cloud, or at least your cruise control is being adjusted from the cloud. How are you going to incentivize people to turn that on? If they don't perceive a direct benefit from that, they might not do that. And they might actually feel uncomfortable because other people around them are driving differently or honking the horn at them. So in order to address that, we have to have the AI needs to actually adjust the controls in a very subtle manner that people don't feel uncomfortable. And furthermore, we need to work with people like Tim to create other incentives for people to turn the systems on, like transit credits or something similar like that.
Yeah.
So the challenges.
Oh, the challenges of implementing new technologies?
Yes, exactly.
Yeah, there's a lot of challenges. We could talk about that for a while here, but I'm gonna say one, risk. It's always risky. You don't want to fail. When I worked in the public sector, one of the things that I tried to instill in our team, it's okay to fail. You learn more from failure than you do from success, but understand how you failed. And most public agencies don't want to take that risk. And I think number two is procurement processes. Many times, how many of you are in the public sector? Is anybody in the public sector? You? Okay, so typically you go out with a tender or procurement, you write a spec, and then industry feeds you back. Then you're really asking for an iPhone 4. Do you really want an iPhone 4 when there's an iPhone 12 or 13 out? And so and what we tried is run proof of concepts to understand what's the problem that you're trying to solve, how we're going to solve it, give you an idea how to solve it using the latest technology so you can arrange or assemble your tenders in the right format to get the best options. And I think the last is Tim was mentioning this, is what are the business models that support newer technologies? Because when I worked for Caltrans, once we trained a diesel mechanic, Ford would pay more and that you'd lose your diesel mechanic. You're seeing that now in public agencies with your IT staff. So how do you keep IT staff when Amazon Web Services or Facebook are offering more money and taking your employees away? And so I think the opportunities today are you can start focusing on those things that you should focus on and then I think Tim talked about this very briefly, but he has 20 people. So those 20 people focus on essential things internally that are going to help change the world, if you will. And then he contracts out to the private sector those other things that have to be done on a daily basis, but it may not be innovative. And so I think there's business models, there's organizational changes that we can make, and then leverage technology in ways that you can focus your staff on the things that are going to make you or meet your key performance indicators.
Perfect. Thank you very much. So now I pass everything to our audience. Is there any questions you would like to ask our panel? And then I probably need yeah, definitely. Should I pass that one? All right, Randy. It was you, right? Yes. Here you go.
Thank you. I had a question for Liam and the project on tracking pedestrian movements and displaying information about that. It's very interesting, but I know there is, at least on our side, also a concern with things like that, because you could be distracting the people with the notifications that you are sending. And I'm wondering if you have any opinions or ideas about tackling that concern.
Yeah, thank you for the question. That's really the other hard part of this problem, right? Is making sure that these notifications are not actually a distraction and causing a hazard. So in the case of the drivers of the vehicles, we're trying to focus on using audio warnings and using the head-up display so that we don't take their eyes off the road. And furthermore, we implement a driver attention model so that we only point out things that are relevant. Because the last thing you want to do is go into a section with lots of people and have warnings all the time. And eventually you're just going to turn the system off and it's useless. Now in the case of the pedestrians, you're right, having the cell phone buzz right when they're in the road might not be the best idea, right? But what the other benefit that the pedestrian can get is that with their permission, the opt-in of course, because we take privacy very seriously, they can share their location with the system in the cloud in some anonymized form. And as a result of that location information being shared, that is then also useful to provide other drivers warnings of their location. So even if they don't get a warning, everyone around them is being warned about them while appropriate. So they still get the benefit of additional safety, even when there is no cameras around.
All right, thank you.
Randy, there are a lot of companies that are interested in providing services, if you will, for everything from ADAS, supplementing ADAS to full automation. One of the key issues is cybersecurity. So if you're sharing data, how do you make sure that the data is coming from a reliable source and then not providing a false data, almost like a ghosting of a signal? If someone comes to you and they've got the ability to crowdsource or to aggregate data sets, can Amazon provide more than just cloud storage? Can they provide strategies for cybersecurity and other elements of how data gets utilized? Because I know a lot of those companies that are beginning to aggregate data like this are concerned that they can stay current with the latest in cyber and other similar privatization, for example, anonymizing the data. Do you help with that, or are those separate and apart from what Amazon provides?
So Rob, there's multiple verticals that we reside in. So we have a vertical leader, Casey Burns was on that picture. He leads verticals. So we have transportation, justice and public safety, health and human services, elections, finance and administration, public utilities, grants, and also cyber. So Maria Thompson's was a Marine. She's always a Marine, but she's retired and she's now working for AWS leading up the cybersecurity. So all cloud providers have security protocols. In our case, we have a shared security model. We take care of the facility. We take care of the cloud. Like if you store your data, you take care of your data. You can encrypt it at rest or you can encrypt it in transit. You set the identity and access management. So I had IAM there. You can have multi-factor authentication where I go to my bank account, it doesn't recognize a computer, it pings me, are you really Randy? And so these factors can help you make sure that your data is secure. Then we have endpoint security, CrowdStrike. There's other partners that we have that can help architect, and that's where Ravi Talluri, who has architected the Ford's connected vehicle data platform, they're worried about all that data. But they got to store it in the cloud, otherwise they're going to have to store it on-prem. And so it's a joint partnership, it's a shared responsibility. And if you get really specialized, then we bring in those heavy-hitting partners that come in and help you secure the cloud infrastructure.
So we see a nice example of when Amazon and Nissan and Transport Authority is collaborating in a system like this. But what is happening when Microsoft and BMW and Orange County is doing something similar? Will there be any kind of standards? How will it work? Or will it be different like islands of how vehicles are communicating in the future?
That's actually, and I'm sure Randy will kind of touch on this too, is obviously setting standards is going to be really important in terms of what we're doing. And so that's it. The system that we're developing like I mentioned, we've got Gomentum Station, and through Gomentum Station, we're working through other private partners, understanding what the direction is and the policies that we'll need to set in terms of implementing projects like this. And so we have, through the Automated Driving System grant, I mentioned that we're basically establishing the data standards and the rulemaking for this connectivity with autonomous vehicles. And so a big component of the grant was developing an actual data management plan. And through that data management plan, we had to develop standards in terms of sharing, for example, basic safety messages that Liam is talking about, as well as multimodal standards. And so all of that is being memorialized through our data management plan, and then that's being shared through a cloud system, through AWS, that then goes to US DOT, and they're taking that data and those standards that we're developing as part of the grant and using that to set standards and rulemaking nationwide for a lot of the work that we're doing. And so it's really interesting that the fact that we're a small agency, but we're actually setting the standards at the local level, at the state level, and also at the national level relative to these types of projects.
What I think is really innovative of what we're trying to do is that we're working with an internet connection, right, and trying to develop apps. And so instead of having to pack all this information through a very restrictive standard, which is good in some cases, but by having our computation in the cloud, by having this larger pipe, there's actually a lot more freedom to experiment with different ways of communicating basically the same information and then processing it in a way that is useful. And some of the information, like locations, is standardized. Other things that we're working with is still not yet standardized, and we have to continue to experiment. And to that effect, we also participate in the SAE standards committees. And so, in fact, the SAE have a vulnerable road users steering committee that is trying to bring together various OEMs as well as bicycle manufacturers and other pedestrian advocates to also come up with standards for this.
From a cloud perspective, it's not going to be the cloud that's going to cause a problem, or the data lake architecture. It's going to be the regulatory framework that you're referencing. You can go cloud to cloud. That's not going to be a problem. And Ali, DavTech now, but he used to work for Amazon Web Services. So it's engineers like Ali that can help design the architecture, like Tim's. So Tim has a data lake to ingest all of this data from connected vehicles, but it's how you ingest, what the points of entry are, and then the regulatory framework on how you're going to analyze that data. Then once that's done, you can architect whatever you want in whoever's cloud. It's not going to matter. Does that make sense?
Awesome. Is there any other question? I'm trying. Someone here. Oh, sorry, I didn't see you. The light was in my face. Here you go.
Thank you.
Of course.
In your systems and your visions, you try to work together to predict the traffic behavior. Is there in your vision a system also placed for vehicles, traffic that is not predictable? For example, emergency vehicles?
Test. Hello. Yeah. So that is also part of the in terms of the different. This connected signal system, as well as connecting that with what we're doing in the highway corridor. So in terms of doing incident management, evacuations, first, all of those types of vehicles will be set up to be prioritized in these corridors using technology. And so doing that through, for example, we just we're getting ready to select a provider to do a cloud-based transit signal priority system that'll overlay on top of the traffic signal system. And so that'll go hand in hand with emergency service providers, emergency vehicles, as well as evacuation. Because in California, we have a problem with fires. And so there's also issues in terms of how do we evacuate people from their homes on these local roads, in terms of getting them out on the highways, et cetera. So that's all part of the plan in terms of incident management. Because the faster we can address that and also deal with the incidences that are on the highway corridor, the faster we can flush out congestion and move people again in the corridor.
Hi, I'm George Aude, CEO of Dirk. I have a question regarding some of the pedestrian safety applications. So at Dirk, just to give you a big background, as MIT spin-off, we've been developing analytics and V2X applications, really focusing on smart infrastructure. So pedestrian safety is a big applications, and we have it been tested for some time in California and Michigan and other places. So the use case you mentioned is very relevant because in the future, cars will be autonomous, but not every car will be autonomous, and sensors won't be on every single car, which we fully agree with. We've been testing these applications. We have it commercially available. How can we leverage what we've done and tested for some time so that others are not trying to recreate the same things, and we kind of take it to the next level. We try to commercialize it. We try to work with the telco players so that we're not just piloting it, taking it to a scale. So this is kind of an open-ended question, but more specifically on how do we leverage what has been done elsewhere, and more specifically, which I can talk to you offline, how can we use what we've done in Michigan and other places to maybe accelerate some of your timelines?
Thank you. Thank you. I'll just try and answer that briefly. Right? I think the really enabling factor in pushing this forward is using an internet connection again, not relying on DSRC or CV2X, those standards which are they optimize for low latency, but they have very low penetration rates, whereas everyone has a mobile phone. And most cars now also have a TCU that allows them an internet connection. So if we can first address those use cases that do not require millisecond timing precision, then we can extend this service to all connected customers, so all the people with cell phones and cars, and we can actually build this into the infotainment system, or even try to retrofit this into the infotainment system. So that's my view as to how we can scale this kind of technology much more rapidly with the cars that we have today, rather than waiting, and not just with the cars that we'll have tomorrow.
Thank you. Hi. I have a question for Nissan, and it's a very technical question. Regarding that notification for the drivers, what input information do you use? So one is public cameras, the other is if the pedestrian agree to share their location. Are there any other input information?
Good question. Is for the drivers themselves, we can make the warnings be much more specific if we know where the driver is going, right? If we know the intention of the driver. So if I know the person is going to turn right, then I can provide warnings for pedestrians on the right and not on the other side. And our system relies on the navigation system to provide that information. But there's actually a whole SAE standard on this. It's called Class B Intention Sharing Collaborative Driving Automation. And that that intention can come not just from the navigation system, it can also come from sharing the indicator status, or as the vehicle itself becomes more automated, of course, it has more information about what its intention is. So that is the main information that we use, is shared intentions, shared locations, and then also information from infrastructure cameras, which can tell us where something is, but not what it's planning to do.
Perfect. And that concludes our panel discussion. First, again, thank you very much from our panel. Thanks for your time. Really appreciate it. And then we learned a lot, and it was a great discussion. And thank you all for attending this discussion. Thanks.